All right. Yeah. So welcome back. So welcome back to my YouTube channel. Welcome back to this YouTube channel. Right. So in the last video, I have introduced you to the problem of object detection. Where we can build computers. We can build algorithms in computers, and enable these computers. To detect not only the class or the type of the image or the object, and we are also letting the computer detect the location or the location of that object in a specific image or in a specific frame of an image or a video. Right. So now in this video we are going to look at some more a little more theory in the space of object detection. Right. So it is not a very complicated science. We're not like, I think the current topics that we are going to learn, uh, like, we are not doing any neural network stuff. We are just looking at some functions, right? So the first thing is, how can we evaluate, or uh, how can we determine how good our model's prediction is, right? Yeah. So the first thing we should do is, like, we have the like the loss function, right? So how can we determine the performance of the model in terms of the location of the object, right? So let's say we have an image. So, right, let's say we have an image, and this is the object, right? And then this is the, so let's say this is the prediction, right? And then this is the actual, right? So as you can see here, so we have training, so we have training data set, right? So in the training data set, while solving the problem of object detection, we'll not only get the class of the object, we also get the bounding box, the actual bounding box, or the actual location bounding box. As you know, object detection, we let our computer draw a circular box around the object that we are around the object that we are dealing with, right? So we'll have this actual bounding box, which is, let's say, this box. And then this is the computer prediction, let's say this is the computer prediction. So how can we evaluate how good the prediction of our computer is, with respect to the actual output, right? With the actual outbounding box. Well, we have a very simple formula here. We can just say that is equal to how the betterness of the model equal to the intersection by the combined area or union. So that is why it is called intersection over union. Yeah. So it is called intersection over union, because we are calculating the amount of intersected area. That is the intersection of area between the both of the bounding box. So this is the area. So the intersection, like, we have these two bounding boxes, and the intersected area is the area, like like we want this area to be as much as possible. So the more the intersected area, the better our prediction of model is. And then the union is the combined area of both of these rectangular boxes. I hope you understand what we are doing here. So we are just getting, so the lesser the union, right? So the lesser the sum of both of these boxes, the better for the model. And the more, and we want the intersection area to be more, such that we can trust that both of these bounding boxes are on top of each other or closer to each other. So this is the terminology of calculating how good the prediction of a model is. Here, the higher the IOU, right? So if IOU is higher, right? So if IOU is very higher, then that means the prediction is pretty good, right? Wonderful. So now, and then, yeah, that is how we calculate IOU, the intersection over union, the intersected area between two bounding boxes, any two bounding boxes, divided by the overall area of all of this overall area of the combined rectangulars. So the lesser the, so yeah, I mean, you can understand, right? If union is lesser, that means they are on top of each other. And if the intersection is lesser, that means they are far from each other, right? Now, now let's look at let's look at a problem that we might face while doing object detection, right? So let's say we have an image. Let's say this is the class, I'm going to do a dot here. So let's say, so the problem is, like you might use any type of model here. So the problem is, like, what if the model predicts multiple bounding boxes, or what if the model predicts multiple bounding boxes for the same class? Let's say we have only this object, sorry, same class, no, not sorry, same object. So let's say we have one object, one dog, let's say. And what if we get, what if the model predicts multiple like when we are using most of these object detection models, we will get this problem, right? So we'll get multiple bounding boxes for the same object, and that is not a very good thing. So how can we delete these bounding boxes, right? So such that we might only have one bounding box. So the process is pretty easier. The process is very easier actually. So first, as you know, like, if you have been in the journey of machine learning with me, or if you are um, well equipped and do have some experience in the field of AI and machine learning or deep learning, you might know that every prediction that a model makes, it will be a probability, right? So for every bounding box, we'll get a probability, right? So probabilities are like when you look at activation functions, every model will output a probability. So each bounding box will have a corresponding probability, right? So let's say this box has a probability of 0.9, and then another box, let's say, has a probability of 0.5, like that, or another box has 0.6, and so on. So what will you do is, you will simply pick the box with the highest probability, right? So what according to the model is the highest probable bounding box, you just pick that. And then what will you do is, like, let's say I'll just draw a clear picture for you. This is the image. Zoom that. So this is the object, right? So let's say this is one bounding box, and this is another bounding box. So this bounding box has a probability of 90%, and then this box has a probability of, let's say, 60%. We're going to reduce the size. Just going to, so let's say this has probability of 0.6 or 60%. Wait a minute. Let's say it has a probability of 60%. So first what we'll do is, as I told you, we'll take the box with the highest probability. That is according to the model, of course. So we'll get the highest probability box, and then what we'll do is, we'll calculate the IOU, the intersection of over union, which we have discussed just before a minute, I guess. So we'll calculate the IOU, right? So how closer both of these bounding boxes are. So essentially, IOU, intersection over union, will tell you how closer two bounding boxes are, like the distance between two bounding boxes. And then what we'll do is, we'll calculate the IOU. Let's say it is 0.5. I'm just going to pick a random number here. So let's say it is 0.5. So what we are going to do is, right, so we are going to set a threshold. So threshold is, let's say we are going to set a value, right? So let's say I'm going to pick 0.6. So what I'm going to say is, if the IOU is greater than 0.6, if IOU is greater than 0.6, that is, there is more intersection, right? So there is more intersection, that both of these bounding boxes are closer to each other, then I'm going to delete this box. I'm going to delete the box with less probability. And then if the IOU is less than 60%, let's say if the boxes are a little bit far from each other, right? So I'm going to leave the boxes. Why am I going to leave the boxes? Why am I not going to delete the box if the IOU of the two boxes is less than 0.6 or any threshold number? Because we never know, right? So if two bounding boxes are for different objects, let's say we have two bounding boxes, but they are for different objects, right? Let's say the distance between objects is let's say a little bit less, then what I'm going to do is I'm not going to delete the bounding box for the other object. So I'm going to leave it. So this threshold should be set very carefully. So this threshold defines how closer two objects of different classes or same class can be. So we should make sure that we set a pretty good threshold, pretty intelligently, right? So we should pick this threshold very smartly and carefully, such that uh, like for different problems we will select different thresholds for different problems. Let's say we are dealing with problems in which both of these objects, like two objects, can be very close to each other. Then we are going to say we are going to set smaller IOU or greater IOU. Yeah, we are going to set um, intersection over union, right? So the distance, let's say we are dealing with objects that are close, that can be close to each other, then we should make sure that we do not delete closer bounding boxes. And then if we are dealing with problems that have in which objects are very far from each other, then we can set threshold as per that problem. So hope you understand what is going on here. Hope you understand these two terminologies of object detection, right? Intersection over union and non-max suppression. So NMS is also called non-max suppression. The method I have shared with you now, right? So the all this method is called non-max suppression, in which we just delete the unnecessary bounding boxes. When you have more bounding boxes, we are just going to delete these bounding boxes. So yeah, thank you for watching, and yeah, see you in the next video.